There are more stars in the universe than grains of sand on all the beaches on Earth. That's at least a billion trillion. But how many of those stars have planets around them? And how many of those planets could support life? These are some of the questions that NASA's James Webb Space Telescope is trying to answer. The JWST is the most powerful and complex space telescope ever built, with a goal to look back in time and see some of the first galaxies that formed after the Big Bang. Recently, JWST made a stunning discovery. It found several large and metal-rich galaxies that existed when the universe was only about 800 million years old. These galaxies are much bigger and more evolved than expected for their age, challenging our current theories of galaxy formation and even evolution. How did these ancient galaxies grow so fast and have so much metallicity? What does this mean for our understanding of cosmic history? And what else can the JWST reveal about these mysterious objects? Let's find out. Scientists have been perplexed by the existence of supermassive and ultramassive black holes because most modern theories cannot explain how these black holes could have formed and grown so quickly, acquiring billions of solar masses in just a few billion years. According to some theories, these black holes have existed since the beginning of time and were already very massive when the universe first began. These are referred to as primordial black holes. More exotic alternative explanations even suggest that the universe never truly began, and that all of this is simply evidence that the universe was always present and never truly expanded. However, the massive black holes, the presence of relatively well-developed galaxies early on, and the extremely recent discovery of yet another galaxy that existed about 1.4 billion years after the universe's formation, but was already relatively high in metallicity compared to our own sun. All of this together creates a bit of a problem. The most recent observations appear to contradict previous predictions, particularly those based on various simulations. It appears that stars, galaxies, and black holes are growing and developing much faster than anyone could have predicted. For the past few months, scientists have been struggling to explain everything, and the detection of these new objects definitively shows that the early universe is far more mysterious than anyone ever imagined. James Webb's primary goal is to investigate the formation and the evolution of galaxies, particularly in the early stages of cosmic history. Webb's infrared vision is used to peer through dust and gas that obscures visible light and captures images of distant galaxies billions of light years away. One such image is Webb's most recent deep field image, which shows never-before-seen details in a region of space known as Pandora's Cluster Able 2744. This cluster is the result of a massive collision of 4 smaller galaxy clusters that occurred over the course of 350 million years. The image shows thousands of galaxies of varying shapes and sizes, some of which date back to when the universe was only 500 million years old. And thanks to JWST, for the first time, scientists have discovered an intriguing galaxy in the very early universe. This galaxy existed when the universe was only about 800 million years old. This galaxy has important properties that could explain why the James Webb Telescope has discovered so many unusual galaxies in recent months. This galaxy is unique because of its extremely high metallicity, which is a measure of the abundance of heavy elements such as carbon, oxygen, and nitrogen in comparison to hydrogen and helium. Despite being formed relatively early in the universe's history, this high level of metallicity indicates that the galaxy had already gone through several generations of star formation. The galaxy represents what appears to be the most powerful and active starburst galaxy ever discovered. The starburst galaxy is a galaxy with an extremely rapid rate of star formation. This means that stars are being formed at a much faster rate than in other typical galaxies. More importantly, it is very difficult to detect starburst galaxies. Once again, discovered pretty much by accident. The galaxy appears to be invisible at many other frequencies, but it was discovered thanks to the ALMA Radio Observatory in Chile. The galaxy bears no resemblance to any of the other galaxies that we know. Instead, it appears to be a very large, extremely active, dusty blob with something very powerful in the center, surrounded by multiple smaller blobs. This unusual galaxy also has a high level of ionization, which is a measure of the number of electrons removed from the galaxy's atoms. This high level of ionization indicates that the galaxy's center contains a very active black hole that emits a lot of radiation. This active black hole is known as a quasar, and it's one of the universe's most energetic objects. In the early universe, the early formation of an active black hole may have resulted in the formation of massive and well-developed galaxies. The active black hole's radiation would have heated up the gas around it, preventing it from cooling and collapsing into stars. Instead, the gas would have been forced to form a large rotating disk around the black hole, from which stars and galaxies would have formed. This process may also explain the discovery of supermassive and ultramassive black holes in the early universe. These black holes could have formed as a result of the direct collapse of gas clouds that were heated and ionized by the radiation emitted by the active black hole at their centers. This process would have allowed the black holes to grow at a breakneck pace, explaining their enormous size. This galaxy's properties indicate that it is a protocluster, which is a system of galaxies that is just beginning to merge. Protoclusters are thought to be the building blocks of larger clusters, which are the most massive structures in the universe. This galaxy appears to have a significant amount of neutral hydrogen gas, which is required for star formation. The presence of so much neutral hydrogen gas in the early universe suggests that this galaxy may have played an important role in the formation of stars and galaxies. However, many questions remain unanswered. How did this universe's first galaxies form? How did they change and grow over time? And how did supermassive black holes appear so early in the universe's history? There are questions that scientists are still trying to answer, and new discoveries like this one will undoubtedly help them. Another question raised by this new discovery is what it means for the steady-state model of cosmology. According to this model, the universe has always existed and has never truly expanded. The steady-state model of cosmology was once a popular astronomical theory that proposed the universe has always existed and has remained constant over time. Recent discoveries in cosmology and astronomy, however, have called this theory into question, and it's no longer regarded as a viable explanation for the universe's origins and evolution. Given all the new findings, the steady-state model of cosmology no longer makes much sense. Modern cosmology observations and experiments have demonstrated that the universe had a beginning and has changed significantly over time. These observations include cosmic microwave background radiation, the abundance of light elements, and the universe's large-scale structure. Also, for the first time, carbon dioxide has been detected on an exoplanet thanks to the James Webb Telescope. WASP-62b is an exoplanet that orbits a star 600 light-years away from Earth. It's a gas giant like Jupiter, but it's much hotter and closer to its star. Webb's spectrograph instrument was used to analyze the light emitted by the planet as it passed in front of its star. Webb was able to identify various molecules in the planet's atmosphere, including carbon dioxide. This discovery is significant because carbon dioxide is a key component of life as we know it on Earth. It also implies that WASP-62b has a complex chemistry, which could reveal more information about its origin and history. Who knows? Maybe WASP-62b is home to some extraterrestrial beings who breathe CO2 and use its complex chemistry to make their own version of carbon-based life forms. It's always exciting to speculate about the possibilities of life beyond our planet, isn't it? We hope you enjoyed this video. Make sure to subscribe, like the video, and watch these ones as well.